Welcome to the brief presentation on how to conduct an independent samples t-test in SPSS. This presentation will cover SPSS data entry, how to conduct the test, how to create a bar graph in SPSS, and how to interpret and present all of these results using current professional conventions. Here is our example scenario for this presentation. It says a social psychologist working for a marketing department wants to study the effects of scenario descriptions on charitable giving to a child hunger organization. He devises two scenarios, one in which an employee of the charity describes group hunger using facts and information, and one in which a child describes their experiences going hungry. 10 people are randomly assigned to each group. After hearing the information, either facts or from a child, the participants are then asked to state how much money they would donate to the charity to help end child hunger. Is there an effect of the scenario type on information or amount of money donated? The data are also shown here, but just take a second to think about what is the independent variable? What is the dependent variable? The independent variable would be the scenario type, either the facts or listening to a child, because this is what is being manipulated by the researcher. But what is the dependent variable? This is what is being measured. It is believed to be affected by the manipulation of the independent variable. So in this particular example, it's the amount of money donated. Notice this is a non-directional test. Now, let's get started on analyzing this question in SPSS. First, we must enter the data in SPSS. Create a new data file and enter the data shown here. When entering data for an independent samples variable, it'll be a single column. Then we will create a second column to identify group affiliation. So you will be creating two columns to enter this data. The first column we will enter ones and twos in data view. Then go to variable view to create labels. One for facts and two is for child. The second column of data in data view will be the numbers shown on the slide, the amount of money willing to be donated. Make sure the data correspond to the correct grouping number. Have your data file created before moving forward. The data view on this slide shows you how the data should be entered into SPSS. In the variable view, you have the two variables represented. The independent variable scenario type was entered using ones and twos to represent the two conditions or groups to which people were randomly assigned. The dependent variable money is the amount donated to charity. So in this variable view, you see the names of the variables. I've selected the values box for scenario type to show you the dialog box for value labels. To show you that group 1 is labeled facts and group 2 is labeled child. This is really important so that your charts will be correct later on. I highly encourage you to be following along creating these files in SPSS. So stop now and get caught up if you have not already done so. We are now ready to calculate an independent samples t-test in SPSS. Click on Analyze in the menu bar, then choose Compare Means and Proportions, then Independent Samples t-test. Now, our first step is in the dialog box to move your dependent variable into the Test Variables box. For step 2, move your independent variable into the grouping variable. For this, you will need to define the groups. So step 3 is to select on the define groups. And then you'll enter the two values you've ascribed to your two groups. In this example, we've assigned ones and twos, which is the default in SPSS, but literally means nothing. You could choose any numbers you want as long as you're consistent with how you entered the data and what numbers you put here. Once you click or put your specified values, click the Continue button. Now you're on to step 4. Make sure the Estimate Effect Sizes is selected. And then finally, for step 5, select OK. Note it is inactive until you defined your groups, which is why it looks inactive on my slide. Once you select OK, the test results will be shown in your SPSS output viewer. Here's what your output will look like. Your mean and standard deviations are provided in your group statistics output. In your independent samples t-test output, you see two lines. To know which line to read, you first look at the Levene's test for equality of variances. This tests whether the data meets the assumption for homogeneity of variance. It is testing the null hypothesis that variances are similar. So it's a good thing for it to be non-significant, which means greater than 0.05, because this means you get to accept your null hypothesis that the variances are similar. If it is non-significant, you use the top line of data boxed in green. If it were significant, which means that that p-value for Levine's test in the red box is less than 0.05, you would also be able to use your data, but you use the bottom row for equal variances not assumed. So based on the data shown on this slide, we get to use the row that says equal variances assumed. Once you know which row to read, you disregard the numbers provided in the Levine's test. In the green box, which is relevant information to this particular example, we see that our t obtained is 2.383. The degrees of freedom is 18, and our significance level is 0.208. This is smaller than 0.05, so we get to say there is a significant difference. Please see that this states that that is clearly a two-tailed test. However, if you wanted to read the one-tailed test, you would just read the line from the one-tailed p-value and you would report a p-value of 0.014. Either way, though, it's significant. To see why it significantly differs, we look at our group statistics. We can see that the group who listened to a child donated more money than the group given facts on child hunger. And the last thing we would need to look at is the effect size. Now we can use Cohen's d because it's provided by SPSS. You would use the point estimate value shown here. Note that sign doesn't matter. So negative or positive, you're just going to report 1.07 or 1.066. It's the same whether you report it with or without that negative sign. Here's an example write-up using professional conventions. You have to report the degrees of freedom, which were 18, the t obtained, which was 2.383, our p-value, which is 0.028, our effect size, which was the Cohen's d, which is 1.06, and the 95% confidence interval that was provided in our output. We will clarify that it was two-tailed, and we will say that we get to reject the null hypothesis. Now we need to say how or why. So we would report the means and standard deviations, and we would italicize and capitalize the M for mean and the S for standard deviation. And you would present it for both groups as shown here. The groups given facts about child hunger donated significantly less money with a mean of 19.1, standard deviation of 7.06, than the group who listened to a child with a mean of 30.5 and a standard deviation of 13.38. Definitely feel free to take a screenshot of this or pause it here so that you have this as a good example on how to write up an independent samples t-test using professional conventions. To graph the results of an independent samples t-test, you would create a bar graph. To do this, on the menu bar, select Graphs, then Chart Builder. Select Bar in the gallery, then click on the first one shown. It will say Simple Bar Graph. Now that shows in the preview area. Step 1. Drag your independent variable onto the x-axis and drag your dependent variable onto the y-axis. Note, the independent variable should always be on the x-axis and the dependent variable should always be on the y-axis. Step 2. Select Display Error Bars and select Standard Deviation. Change the multiplier so that it is to number 1. And in the element properties, make sure the statistic for bar 1 is mean. And your final step number 3, click OK, and your graph will appear in your SPSS output. Here's what your graph will look like when you have it set to APA format like we set previously in the course. But as we covered, this still isn't perfect, so we're going to have to make a few modifications. Here's 3 things that immediately jump to my attention that are not APA, so they need to be deleted. I also like to make my bars black, but that's optional. If it's grayscale as shown here, that's also totally fine with APA. So make all the changes that you know need to be made and click on the next slide to check your work. This is how you would write up and present a figure using APA conventions. The figure and number would be bolded, and then double space below that is the title and title case of your figure. Our bar graph has no background lines. It has error bars, and it has an X and Y axis all in title case. And then there's a note below it. The note is italicized and it says listening to a child resulted in significantly higher donations than listening to facts, and our p-value is presented. Now, if you have a bar graph, you don't need to also report the means and standard deviations because that is represented in the bar graph and thus would be redundant and a waste of your time. So this is how you could write up your results given the inclusion of a bar graph. You could just refer to it. This is called a call out, and I've shown you in this presentation how to do it within a sentence. As shown in figure 1, the group given facts about child hunger donated less money than the group who listened to a child describe being hungry. Let's just pretend that the output would be different. I want to show you how you would write up results if your p-value was above the 0.05 that we set for our alpha. Now our signum column says 0.47. This is above our alpha, so we would fail to reject the null hypothesis. This means we conclude there's no difference. Now, if there's no difference, you still report the effect size and the confidence intervals, but I just wanted to show you how to write up results if it's non-significant. So this is an example on this slide. An independent samples t-test found no difference in the amount of money donated based on how child hunger is described. T, degrees of freedom, T obtained value, p-value, r squared, or you could have your effect size, the confidence interval, and you'd write it's two-tailed. People donated similar amounts of money regardless of how the information was presented. So again, putting it into what does this mean words in a very succinct manner. So this concludes this presentation. We showed you how to enter the data, how to conduct the test, how to create a bar graph, and how to interpret and present results.